Hello. In this video, we're going to talk about the volume of different prisms and pyramids and things like that. So the general formula for volume of an object is a very simple one. The volume equals the area of the base. I'm just going to put a big A times the height. So what we do is we figure out the area of the base or the area of the top or the bottom or whatever, and then we multiply it by the height. So let's take a look at some basic ones. This is basically just what we would call a prism. Inside here, we got a little bit of shape, and let me bring this down. Okay, so if we looked at the bottom of this thing, we see it's got 2 inches, 3 inches, and this would represent the height, how high it's going up and down. So the volume is equal to length times width. That'll give you the area times the height. So on this one, we're going to multiply 2 times 3 times the height. And let's change that height to 4.5. Just make it a little bit easier. Then we don't have to deal with all the fractions and stuff like that. So all we got to do is whip out our calculator and see if we can figure this out. So we're going to multiply 2 times 3 times 4.5. And we find out the volume is 27. And this would be cubic inches. These all have to be in the same dimension, of course. So this would be inches cubed. So volume is always in terms of cubic, power of 3. Here's another one that's a little bit more difficult. I'm going to start out with our basic formula. Volume equals area times height. But we see this side right here is a trapezoid. And that's what we're going to do. We're going to figure out the area of the trapezoid, and then probably, instead of height, we'll probably use the length of this thing. So the volume is going to equal to, let's see what the area of a trapezoid is. It's height times base 1 plus base 2 divided by 2. And then we're going to multiply it by the depth of this thing. So we'll call that the length, okay? So that's how we're going to calculate this. Now, what dimensions do we need? Well, let's rotate this a little bit. Okay, this looks like base 1, and this is base 2. These are the two sides that are parallel to each other, okay? And these are not parallel. So let's see what we can do here. We're going to use 18 and 6 as our bases. 18 plus 6. What about the height? Well, the height of this object has to be perpendicular to the base. So this dimension right here is going to be used for the height. 16. This dimension we're not going to use at all because that's kind of a slant height, and we don't want that. So here's the base 1, base 2, and the height. And then the length going back, or the depth, is 14. But first we want to divide that by 2, and then times the 14. So just to learn order of operation, let's do the parentheses first. 18 plus 6, 24. Multiply that times the 16. 384. Divide that by the 2. And I kind of messed up here. Let me go again. 18 plus 6 equals times 16 equals. Now we're going to divide by 2 equals. And then finally, we multiply that by 14. It's 14 equals. And this should give us our answer. The volume is 2,688 cubic. And we could write it like that, feet. That's another way of writing it. So let's double check our math just to make sure. This would be 24. And I'm going to divide first, times 8, times 14. See if we come up with the same answer, and we do. So we verified it. So that one was kind of tough. Okay, this next one, we're going to look at the top. The top of it is a triangle. So volume is equal to the area of the top, or whatever you want to call it, times the height. Okay, so what is the formula for the area of a triangle? Base times height divided by 2 times, and let's use a capital H here for the big height. So this right here would be our big height right here, 15. This right here is the base. It has no dimension, but if we look, this is parallel to it. So our base, our bottom, must have been 12. And our height of this little triangle is 5. Got that little H. So we don't really need the 6 or the 9. Thrown in there, maybe for some other reasons, we don't need this bottom 12. These are the dimensions we need, the 12 across, the 5 going up. That'll give us the area of the triangle, 12 times 5 divided by 2. And then once we get that calculated, we're going to multiply it times the height, going up and down to 15. So we're going to take 12 times 5 and divide it by 2. And that is the area of this triangle right here. And now we're going to multiply it by the height times 15, 450. So the volume of this whole thing is 450 cubic inches or inches cubed. So again, we figure out the area of this triangle, and then we multiply it by the height. So sometimes when you're trying to figure out the height, let's use a capital H here. Might be easier. So this in this problem was the height. We'll use right here, we use this as the height on that problem. All right, here we have a square. So that, a cube actually. So we're going to use the same formula. But here we have a pretty easy length times width times, and we'll use a small h now for height. And they're all the same. So this would be 7 times 7 times 7. We could put 7 cubed, or we can just multiply 7. Oops, there are too many. 7 times 7 times 7. 343. And I'm going to write cubic centimeters like that. Or I could write centimeters cubed. So now the object is find the main area, which might be a little different from the rest of them. Calculate that part first, kind of the oddball, and then figure out times the height. And this way, one other dimensions is kind of like the same as a box. A box, pretty easy to figure out. Length times width times height. Here's another box. Length times width times height. So a box isn't too hard to calculate. All right, next page, a couple oddball ones. I've got to look up the area of it. This would be volume equals area of this hexagon times the height. I'm going to use a capital H. The height would be 16. And this is the side. They usually refer to that as small a. So I think, in fact, I kind of remember it. The volume is equal to, the area is 2.598, I think, times the side, 6.5. And then we're going to multiply that times the height. I'm going to double check that formula just to make sure, but I'm pretty sure that was the formula we were working with. Let's see, I had this, and I lost it. Okay, here. Regular hexagon, 2.598. Good. So this is a factor that they give us, a constant, they call this. It's always the same. And then all we got to do is put that into our calculator. So this problem looked kind of difficult, but if you know this, now wasn't it a squared? Let's double check and make sure. Yes, this was a 2.6.5 times a squared. So this is times 6.5 times 6.5. And then that answer, we could hit equals if we want, that answer times the big height straight up and down right here. And that would be times 16. So I come up with 1,756 and 248 thousandths. I'm just going to keep the whole thing in here. And this would be inches, cubic inches cubed. Okay, if I wanted to round this to a whole number, remember, I look at the 6, then I look at the next number, and it's pretty small. So if I wanted to round it off to a whole number, it would be 156 cubic inches. We'll put approximately. Okay, a pyramid. Now, a pyramid has just a slightly different formula. The pyramid is very close. It's the area of the base. Sometimes the base might be a rectangle. Sometimes it might be a triangle. So it's the area of the base times the height, just like we were doing, except if it comes to a point, we divide by 3. That's the rule. If it comes to a point, we divide by 3. So on this one, the volume is 6 inches by 8 inches, It's a rectangle. The area is a rectangle, so we're going to multiply line times width, and then times the height has to be from the very top straight down to the base, not along the side, but straight down in the middle of the base. It has to come right to the base. It has to be perpendicular to the base. So the times the height. So on this one, we're going to say the length is, let's say 8, the width is 6, and the height straight up and down, and they might give it to you, is 10. So all we got to do that is multiply those, but don't forget to divide by 3 to divide by 3 because it is a pyramid. So 8 times 6 times 10 divided by 3. Because there's no addition, we can just multiply everything and hit the division. If there was addition, we'd have to be a little bit more careful. 160 inches cubed. Okay, the last one, not a great drawing. I had to draw it kind of upside down. So this is an upside down pyramid you can kind of think of. Not much of an artist here. This should actually be 5 inches. Okay. So we're going to find the volume is equal to the area times h divided by 3. The area of this triangle. So the area of the triangle is base times height divided by 3. And then we're going to multiply it by the big height, which should come to the middle right here. Kind of a poor drawing. Not very well drawn, I guess. But the height comes right to the middle. The height is going to be 8 inches. So we'll put a big H. So the volume, let's find out. This is actually going to be your base. And this is actually going to be your height because they have to be perpendicular to each other. They got to be at a right angle. So this is our small height. So it's kind of deceptive. You might have thought this was it. But they didn't give us that dimension. Well, they did. They gave us 5, but we're not going to use it. So we don't need that. It's going to be 3 times 4 divided by 3 times the big height, 8. So this will cancel and this will cancel, or you can multiply it out. It could be 12 divided by 3 is 4 times 8 is 32 inches, cubic inches. We'll write it that way. 32 cubic inches. So that's kind of the whole idea of trying to find these things. Sometimes they're kind of hard to do and not always the easiest, but that's how we find the height of a thing that has a prism or a square for the base. Let's see if we can do any here in the book. Let's try a problem like this one right here. How would you do that one? Okay. See how it comes to a point? The volume is, we're going to do this number 3, base, the area of the base times the height divided by 3. The volume in this case is this area, and it looks like a square, huh? So it would be length times width, and then the height would be the whole distance here. That they kind of had to show it that way. Let's see. So we're going to assume the height is 30. So we use a capital H. So it's 32 times 32 times the total height, which was 30. And then we're going to divide the whole thing by 3. So we want to multiply all these, then divide. So the volume is 32 times 32 times 30. But then don't forget, we can just hit enter if we want, but don't forget to divide by 3. So 10,240, and this was cubic feet, cube. So that's all there is to it. Try to figure out what they're talking about, and now you know how to find the volume of an object. Okay.